All right. Welcome back. We are going to go to our next talk discussing the BioGears user interface. And this talk is going to be led by our lead software developer, Stephen White. He's also the PI on our Prolonged Field Care project. And so he's going to discuss some of our work developing the BioGears GUI. So take it away.
So for our follow-on project, we wanted to take some time to redefine the BioGears visualization code as we had previously released. So prior to last year, BioGears was bundled with a Java-based UI that could run simple simulations and apply actions in a linear timeline. To maintain that UI, we had to maintain a JNI layer that allowed calls to be made from Java and several duplications of code from the C++ layer. And we thought this was a good opportunity to make a native UI that had additional features and was easier to maintain and compile. So our timeline is we currently have the source code available on GitHub for what we call the alpha release. It supports running BioGears, applying customized actions, and then visualizing data trends from the physiology feedback and substance concentrations in kind of an organized way that we've curated. Moving forward towards December, we want to work towards a unified theme and layout for this, and then to add a couple of curated physiology widgets that match kind of vitals monitors and, applications that clinicians see on a more regular basis. And then we also want to be able to export the data that you've run to save patient states and reload them in future uses of the UI. When we get all of that complete, we have a couple of wish items that we're hoping for like a 2.0 release, which includes a multi-windowed based UI, so you can see multiple categories of data trends that we'll show you in a second, and then a Lua-based scripting engine that would allow you to apply actions a little bit faster than the current WYSIWYG UI does. All of this was developed with the help of Brett Talbot acting as SME for incorporating like what end users of BioGears really need and target so that we could get out of our kind of numerical engine mindset that's just to deliver data dumps and give you more of something that has instantaneous feedback so you can explore and see what's capable of BioGears. So as it stands, this is a current picture of the working UI. We have the ability to select patient saved states and load them, and then to start a simulation and either run it in real time, wall clock time, or as fast as your computer can simulate BioGears, so you can run faster than real time. There is a console which produces all of the log messages that BioGears would normally log, and that's color-coded based off of whether it's an info, warning, or critical error. And then we have a multi-page visualization section, which allows you to display different trends based off of categories that we think that they should be grouped by. So it's kind of a breakdown of the functional components of the UI. There's a fourth section in here because the action selection drawer actually is clipped off screen when it's not on, so that slides over onto the interaction area when you're using it. And so everything from the interaction area to the right boundary is kind of what you see while you're looking at it. And we try to keep as much of the screen utilization space down to the visualization area. At a higher fidelity, we break the UI down into patient parameters, what patient you're running, state, the instantaneous patient metrics like respiratory rate, heartbeat, the ability to control the simulation, and then your user input area, which is where you select the actions you would like to apply while the simulation's running and then have quick access to them. And then we have the navigation bar for scrolling through categories, and the number of widgets that are on screen is also scrollable, so it can exceed 4. And finally, just that small section dedicated to the console so that you can see things beyond just the metrics as they occur. So breaking those down from the visualization we had earlier, the left side is the patient metrics. It has diastolic and systolic blood pressure. It has your current exercising condition, whether you're standing or running, your heart rate and respiratory rate, and then underneath that is your play and your speed toggle, and then on the left is reset. So at any time you just want to start back at the beginning and reload the state, you pause the simulation, reload, all of the graphs will reset, and you can run it again, or you could change patients and run that. The Add Action button activates the action drawer, which we'll cover in a second. But that slides over and gives a list of all the actions you can do in BioGears. When you activate one, you get a custom configuration pop-up that will allow you to set the parameters of that action. And then underneath the Add Action button will then appear toggles for when those actions are activated or not. In the visualization area, we have your current physiology category, and then there are two arrows that let you tap through them. Next to that is what we call a burger menu, which pulls out the categorizations of what can be shown in that category, and you just toggle them on and off as you need them for data selection. Again, color-coded BioGears log, and once they've been selected, they appear in the order that they were selected in. So if you disable one and then re-enable it, it'll be at the bottom of the list currently. This is a picture of the action drawer. While it's extended, it's the only thing that you can interact with in the UI. Actions are, again, kind of arranged in a way that we feel is intuitive to our API. Once you have clicked on an action, you get a modal pop-up which allows you to configure it. And then those actions appear underneath the action bar with a toggle for being on and off. These slides are a little data heavy, but these are the current categorizations that we have, everything that we proposed. BioGears probably has 192 physiology metrics that could be shown, and like an order of magnitude higher compartmental request. So giving full access to everything in a UI is very anti-user friendly. So we've streamed this down to what we feel are the non-static metrics that have the most volatility during a run and react to patient events. And then we've categorized them instead of based off of the system and API layer, more of like a literature-based categorization. So data request, blood chemistry, energy metabolism, and then we have drug substances where you can graph the active drugs, substance nutrients, their concentration, different metrics about them, and fluid levels as well, inter and extracellular for the body. And now I'm going to switch it over to Matt. He's going to do a live run through so that y'all can see it in action, which is far more exciting.
Let's start here. Alrighty. All right, so hopefully that was a fairly seamless transition where people can see the visualizer right now. Let me pull down the chat here just in case. All right, is this visible to people before I start running through stuff?
Yeah, we can see it on our end.
Yes.
Okay, cool. So as Stephen said, this is the general layout. You can see we have a patient drop-down menu, so you can select various patients. We just have default parameters and then some extreme scenarios and various people that we've named in here with different parameters. I'm just going to leave this on default male for now. And so our action console, oops. Doesn't seem to want to close that menu. That is very weird. Okay, what's happening here? Okay, well, that might be a window min-max issue there, but okay. So we log out some of the vital signs. These are also plottable right here. So every single one of these menus has options you can plot. So for instance, you can be plotting blood pressure, respiration rate, and heart rate. Add these to your viewable window. As you scroll along, we have some other cardiopulmonary measurements that you might want. Again, blood chemistry, energy metabolism, renal fluid balance. So this includes filtration rate, urine output, and also kind of body water balancing. Different substances. So these drop downs are all the active substances in BioGears. Each substance has subtypes that can plot, like blood concentration, its mass in the body, etc. When you add a drug to BioGears, it will get added to this menu, so you can plot out features of that new drug. And we also have been experimenting with some custom plots. So all the plots that we have currently are just time series. It's heart rate versus time, blood pressure versus time. We're also looking at adding some custom plots like a respiratory PV graph, so a pressure volume graph as the patient breathes. So until you start a simulation, these are all going to be blank clearly. But I do want to show you just a couple of examples of what this might look like. So this button right here brings out the action drawer that Stephen mentioned. So we try to group these by actions just specific to just the patient can do. They can exercise or consume a meal. Insults to the patient. So these are things that are bad that are happening to them. Interventions, and then various conditions you can apply. Conditions right now are currently not active because that involves loading in some new state functions. Those are their placeholders for now. So clicking each one of these actions will launch an editor where you can specify action parameters. So a simple one we can do is a pain stimulus. So it launches an editor here. You can choose the location. Right now that doesn't have a huge impact on the model, but again, we're trying to get more and more localized with our, so let's say you have a chest pain and the patient's reporting a visual analog score of 7. So you'll see then that your action shows up here in this menu, and you can, this is actually activated. So right now you basically queued your actions, but you can decide when in the course of a simulation to actually apply the action. So just to give you a sense of what else we can do here, let's say that you have some pain, so you'll administer some pain medication. So you can choose the admin route. We've got, again, our bolus drugs, intravenous infusions, our oral drugs, and transmucosal. It's all supported right now. We'll just do an intravenous bolus, and we'll say we're giving ketamine as a pain med. So you need a dose and a concentration. So we'll say you're giving them 20 milliliters. Again, this will net out to about 2 milligrams. I'm not looking to heavily validate anything right now. There's just general numbers to get a sense of what's happening here. So we've got pain stimulus, and then we're going to give them some pain meds once that happens. So we're going to start playing here, and so right now we're plotting out just general baselines because we haven't applied any actions yet. And so you can see in this plot we've got systolic over diastolic pressure, we have respiration rate, and we have heart rate. If you go and add a new plot, so for instance, let's say I wanted to check out the cardiac output, it'll start tracking from the current time that you administer it. So one thing that we do want to do in the future is have BioGears storing a history so that if you add a plot later in the simulation, you still get the full history. That's what we're working on right now. Right now it's sampling at 1 hertz essentially, so it's adding, it's doing 1 simulated second per real second. We can increase the run rate. So this is the maximum that my computer can do right now with BioGears. And let's say that we apply that, we turn that pain stimulus on. You can see that our heart rate starts spiking, blood pressure, respiration rate increase. Right, all these parameters are changing as we apply this action. And so our patient's going to stay, in this this elevated state for a while. And now what I want to do is if I, these graphs are saved, so if you scroll over here, right, it's still plotting out when I come back to it. Well, I want to scroll over to substances here because I'm going to apply this ketamine bolus. And when I look at my substances, I've got ketamine right here. So let's plot out the plasma concentration of our ketamine. You can see just an initial bolus, so we had a pretty high concentration to start off with, and now it's diminishing over time. We can look at how much ketamine is there in the body, and let's maybe take a look at how much ketamine we're clearing as we go along. And so these plots will start to look a little more realistic over time, right, as they get more data involved. Something about minimizing and maximizing these plots is causing some odd behavior here. So let's look at our vital signs now. Well, I guess I was going to look at them. Could be because of the screen sharing too, might be lagging. Well, here's our vital signs again. You can see that our blood pressure got better after the pain medication. Same thing, heart rate decreased, respiration rate decreased. But they're actually starting to tick back up again because the pain medication's wearing off. I probably gave a small dose, so it might not have had too much of an effect. And you can see here in the log, actually, the bottom, it's pretty small here, but the log is actually printing out what we're doing. So I gave a pain stimulus, location, and then the patient has tachypnea, tachycardia. So we're logging events that occur to the console for general use there. So let's pause this one. I think we're suffering here again from trying to broadcast this at the same time here. I'm going to refresh everything. And let's get rid of, add some different actions here. So I want to mention one more thing I think is interesting. So I want to do a tension pneumothorax action real fast. And again, these are just some generic inputs I'm putting in just to kind of see what's happening. But I wanted to show you like what you might get out of this pressure volume curve that we have. So let's say that we have a patient and they're again just breathing normally. I think I may need to reset the whole patient for it to reload. All right, so as you can see, we're still very much in a pre-alpha phase here, but it's getting there. So this would be a pressure volume curve for this patient normally. So you have, right, as the pleural pressure changes, their lung volume changes. But then you add a tension pneumothorax, and all of a sudden, this PV curve starts looking a whole lot different because of what they're able to actually draw in because of the tension pneumothorax action. So it's very responsive, again, to whatever actions we're doing. So some updates to this plot that would be good is if we just stored maybe the last cycle for comparison, or perhaps we stored a baseline cycle, the last cycle, and then show the current cycle, so you can compare all of those as opposed to just overlaying, on top of each other. But we're pretty excited about just the flexibility that we have so far. We think that we can introduce a lot of really neat features to this as we go along. I think I'm going to pass control of this back over to Stephen now. All right, Steve, I think you're good to go.
Okay. Yep, I am presenting again.
Yeah, that was really cool. Just to speak to that pain visual analog, when we were presenting that model, actually when you go into an ER and they ask you, what is your pain like? And it's that 1 through 10 with the smiley face and then the grumpy face. Our collaborators at University of Washington wanted us to integrate that scale into the model. And so you can actually ask for the pain visual analog scale number that the patient is experiencing due to a given stimulus. And then that score will actually scale based on like what opioids, like Matt showed, ketamine, other painkillers will affect it. So that was really great, Matt. Thank you.
So for some technical details before we go forward, the new UI is written in Qt5. So it's native to C++, but it is a big third-party dependency to make all the widget platforms. And then the front-end code is written in a QML, or in QML, which is a Qt5 specific technology that allows us to very quickly, rapidly develop changes to the UI. And so we're very looking forward to what we can do in the visualization department beyond just standard histograms and line graphs, but very tailored ways of showing like bladder volume or the respiratory cycle as we get all of the base features implemented. Currently what we're going to talk about is where we're going with this. And the first thing I think is, as you noticed, you configure all of your actions once, and then they're set. You can turn them on and off, but they're not editable. So we would like to expand the widget size for an action application, and if there are parameters that could be variable, like say sliding down the pain stimulus from a 7 to a 5 live, then you'll have a slider bar for that represents your ability to change it once it's been activated. And then we'd also like to visually distinguish between toggleable or reversible actions for momentary actions that you can just tell BioGears to do. The two that we often discuss are urination and consume meal. Once you've told BioGears to consume a meal, it consumes all of the nutrition. It's basically teleported into the patient's stomach and then absorbed naturally. So we definitely want to communicate that that's a non-reversible thing, and once you've activated it, it happened, and it becomes a log event. We see several places to improve the overall theme of the application and get uniformity on font sizes and types. Definitely in the patient metric stuff, we'd like to have uniformity like color coding for when metrics are exceeding the normal ranges and going into like warning areas and then critical numbers. Currently, the exercise state is just a word. We're gonna eventually switch that with like a icon animated thing to give you like a better intuitive response to what you're seeing that you can absorb quickly. And then we're going to focus on adding support for all of the data exports. BioGears already supports this natively. We just need to be able to tell BioGears to implement all of those exports once it's requested by the user. So some of the improved interactions that we'd like to look at are basically, like you saw Matt change the patient state that was loaded. I would like the list of patient states to match the list of patients that are in your runtime directory's patient folder, and then to have a cascading list, which is all the states that match that patient. So by default, BioGears comes with about 13 to 15 patients, depending on the release. And we store one state for each one of those, which is their initialized state. So you ran them just long enough to get to the 0th simulation second, and then we serialize them out to disk. But you could reuse those patients in a number of ways to put Bob or Sally into, a septic state, or to exercise them for a few hours and then save them out. And because they have different initial conditions, those states should be different. And the ability to recall those states very quickly is what we're looking at. Then to expand on what the toggleable user inputs would look like, these are examples of our ideas for anesthesia machine and a pain stimulus. So you're going to get the name of what you asked for, probably a custom ID so that you can distinguish between two separate pain events if you have them both loaded. And then you're going to get that slidable bar for all of the values that we think make sense. So there are several things on the anesthesia machine that you cannot change. And so to communicate that the only way to switch is to turn the anesthesia machine off and to bring out another one, things like the mask or the connection type won't be changeable once it's activated, but the volume of the tanks that you could refill live and that tick down while that action is available should be presented to the UI. Then for all of those momentary or instantaneous actions, instead of a slider bar, we just want a push button that instantly communicates it's been activated in the log. And if you could, on the next time, change any of the parameters, such as like for protein mail, we will make that available inside of that UI. Now, obviously, this increases the vertical size of the left-hand side of the app, so that's going to have to become a scrollable area so that you can easily identify which action you're going to trigger. And that also implies that maybe we want this to be collapsible, so that while you can expand them to make these changes, you can collapse them just to that toggle and see more actions at a time. So this one we've mostly already created. All of the, if you have 6 or 7 plots open that overflow the screen, they automatically become scrollable. Currently, all of the widgets are 1/4 of the area, and so 4 is all you're ever going to see at a time. In a future revision, we might make them dynamically sizable, but that's very complicated right now with the technology we're using, and to guarantee that there's no clipping or overflow inside of the UI. So for simplicity purposes, they will be fixed size, but you can have as many as you want, and then we'll make it easy to navigate through. So these custom visualizations that we're thinking about, the biggest one that we want is just a customized hold tab that's always the patient vitals monitor. So you don't have to set up those graphs and you see them all together, even though they're normally in different categories. And then we're very interested in doing something that's unique to BioGears, which is providing you with substance concentration throughout the whole body. So you're going to see a representation of the human body that will, and then you're going to configure that visualization to a specific substance, and it'll be start black and white, but as concentrations build up, you'll see kind of like a heat map begin to expose in the parts of the body that those concentrations are in, and you can watch that flow for like the transmucosal model. You can watch that start in the mouth and then go through the throat and the GI tract and everywhere else that it exposes as it enters into the bloodstream. Pulmonary activity and breathing cycle, if we work with artists to get more of like a very interesting part of like the strokes where the airflow is going in, those are very interesting to us, and we think that we'll get a lot of bang for a buck in demonstrating this and like the fidelity of the model. And then any other metric that makes sense for something more than just a line graph. So like for bladder volume, for instance, 0 to 100%, you can definitely imagine it as a circular graph that builds up with just a percentage line. It's more communicative and natural to the end user. And so those are just examples of where we're going, and we do invite feedback to our GitHub issues on top of the visualizer code base if there are other things you'd like to see. If you pull this code base down currently, I think I need to update the build instructions, but it's bundled with the version of BioGears that's compatible with it, and so it will build BioGears for you and then build the visualizer and allow you to run it. So for file export, we're just looking to add kind of the desktop experience to the top. If this was ported to mobile, we'd give a modality that makes sense for that interaction. But there will be a file and an export that allows you to save and target the specific thing that you want to, and then that's going to, in your runtime directory, produce an XML file based off of a standard naming convention or a custom name, depending on how you interact with it. Once we go from there and we have the ability to export, we'll look into loading specific sections beyond just whole patient states so that you can change the environment after they've been loaded and different things. This leads to kind of the ability to modify scenarios as a timeline and schedule events to fire. This is just another example of interaction that things we have to think of are desktop interaction hotkeys that allow you to reload states very quickly based off of like the last 10 that you interacted jump list. So for that scenario timeline, we're looking for another tab to the visualization space that shows you from the 0 seconds to the furthest you've run the simulation or the furthest you've scheduled out to, and allows you to right-click along that timeline and apply events. And so when the simulation time gets to that specific point, we'll automatically apply that, and you don't have to do it instantaneously. Those can be saved out into our existing scenario format and reloaded, and so you'll be able to have repeatable demonstrations to other users about how BioGears react in certain situations. And you'd also be able to use the same scenario timeline against different patients on multiple runs and see how those starting states actually affect BioGears when these events happen. So for future functionality, beyond all of that delivered, which is our like immediate goal that we're insisting we get done by the end of the year, if you remember from Matt's example, you can only see 4 graphs at a time, and they're tabulated or paged based off of what category they're in. So being able to detach those windows so you can have a multi-pane UI and keep up your respiratory graphs at the same time you're looking at your cardiovascular graphs or your GI or substance concentration is an immediate thing that we know needs to happen. And so we have ideas for that. We're experimenting with it. And as soon as we think it's stable, we'll introduce it into the UI. Okay. Oh. Lua, a Lua-based scripting engine, this is more moving from kind of like an end-user clinician early experience to I've used this UI a lot and I have expert results. But this would give you some command line interaction to apply actions instantaneously without going through the setup for them. In addition, I think that the Lua-based scripting engine would allow you to make custom data requests or serialize out different graphs that are currently out to log so that we can write them to disk and save them for you for review. Just a lot of power that's too hard to organize in a UI that we can expose early in a command line interface within the UI, and then later, as users prove that that's important to them, make a WYSIWYG or hotkey version of that. Parallel simulations is a stretch goal that's very interesting to our team and people who run validations, but this goes in line with a talk I'm going to give at the end of the day for the BioGears 8.0 release, but I would like to be able to support branching in our scenario format. And by branching, I want to be able to write a scenario that has multiple possibilities, and when I hit those branch points, I automatically fork the physiology engine and then start running both possibilities in parallel so that I can create state graphs for what could have happened if interactions or insults had happened to a patient very fast. And so if I can do that at the command line, I want my UI to be able to do it. But it does run a problem because you move from instantaneous feedback mode to I want to see to, or I'm going to do a long-term wait and look at like a pending bar until it gets done. So we'll have to minimize to the system tray or something and communicate to users that there is background actions happening. And our final goal is we have a command line utility for BioGears a lot called CMD-Bio. And it has a lot of helpful utilities that are for maintaining the BioGears data state in the back end. And I'd like to find a way inside of the file menu system for advanced features to expose all of that equivalent feature set to the GUI. So I'm going to open up the rest of the talk to questions, if anybody.
Yeah, it looks like Williams and Dan have a few good discussions. So Dan, just real quick, I agree. We would like to have an expulsion of the nutrients from the stomach. Just right now, we don't support it. So that was a good example. for Stephen to use. But like in the future, if we had like a vomit, then you can imagine that you'd be able to toggle that on to get rid of the nutrients. But yeah, that's a good point.
Good point.
And William, maybe we'll just unmute William and let him have the floor for a little bit. Hold on one second. All right, you're unmuted, William. Go ahead and we see your comments, but maybe you just want to give a little spiel about what you're referencing here.
Yes, so the Web3D Consortium, a nonprofit here in America, has a handful of working groups. I have been associated with the Humanoid Animation Working Group. It's animation, not simulation. And I realized that there's a nice clean demarc between the algorithms and rendering those, whether graphically, haptically, or acoustically in 3D. So I just am really excited to be able to get some activity going, taking a look at your documentation and your roadmap, and look at what H&M wants to do and what the Web Medical Working Group and the Web 3D Consortium wants to do to start to integrate and bring the anthropometric and anthropomorphic aspects to the standard browser without, having the user to have special plugins or downloads and all that kind of stuff, and increase the information density without overloading the provider, whatever the setting might be in hospital or field medicine. So there's a lot to connect there, and what little I know about user experience and user interface design, it is an art. And I appreciate that.
Absolutely.
That's all I have.
Okay.
Well, we'll definitely follow up on that and look into it. One of the larger problems that we have is always, as an open source project, finding things that we can include in our release builds that are also open source. So we either, hire artists to make all of our assets for animation and graphics, or, if a repository already exists, then it's very useful to lean off of, because one, familiarity is half of communication. It makes things more intuitive. But also the fact that it's open just makes it easier to distribute.
Yeah, and I mentioned ISO standard, and our particular standard is royalty-free in terms of the standard part of talking about Web 3D graphics and all that is wrapped up into the family of the Web 3D graphic standards, because there are a number of them. So that's the good part. Now, the art part is not going to be free, but you heard me allude to DICOM imagery and a volumetric node set and some other things. So a lot of what I'm not saying is built on a larger discussion about, when we're talking service members, how much do we collect on the member before we put them in the situation where they, they get hurt and they have to be treated. And so when you're, quote, calling up their record, it would be nice once the costs and justification for high resolution multimodal imaging comes into play, that while it might be old from the time that they got injured to the time that they did their DOBMER or something, you would have something that was anthropometrically unique to that person in different modalities to maybe initialize that display. Who knows? It's a complicated discussion, but the idea is that the cost of entry and the availability of that sort of data on an individual between their own devices that they could capture and what the government thinks is necessary to provide the care to the extent that they think they need to do so, it becomes more available.
Agree with that. Are there any other questions? Okay. So I think we'll take a minute to set up the next, and then maybe we can get some time back from earlier and start on it.